Thank you all for coming, and can I get a show of hands? How many of you were able to go to the morning talk about Portlet 3 and so on? Some of you. Okay, I mentioned earlier in that talk that these two talks go together, and as I was talking with Joel beforehand, I realized these two ideas are really inextricably joined together, some of the topics, so it was very hard to know which slide went in which presentation, but the title of this talk is Developing WABs with a View to the Future. And if you are deploying a WAR artifact in Liferay 7, you've deployed a WAB. And I'm going to explain what that's all about and how you can and perhaps how you should develop your WAR-based, your Java EE WAR-based type portlets today with a view to what's coming in the future. If you'd like to follow the tweets for the Liferay Faces team, you can follow at Liferay Faces. Here's our team. I mentioned earlier today Juan Gonzalez, myself, Vernon Singleton, Kyle Steeman, and Phil White. And we're going to start this off by talking about portlets. Okay? This is a topic near and dear to all our hearts, I'm sure. Well, as you know, Liferay 7 implements Portlet 2, but future versions will be implementing Portlet 3. Liferay 7, since it supports Portlet 2, the normal way, the way we've always done it in years past, Liferay 6.2 and before, is to package your application as a WAR. And a WAR is a standard Java EE type artifact, except we would normally add one more descriptor, the portlet.xml descriptor, and if you're deploying to Liferay Portal, perhaps you're going to do Liferay display.xml, Liferay portlet.xml, perhaps Liferay plugin package.properties. But as you know, at Liferay 7, as you've seen at this conference, and actually the last couple of years we've been showing that Liferay 7 supports a vendor-specific mechanism where instead of deploying a WAR, you can deploy a jar, an OSGi bundle. And I'm going to show how that plays in with Java EE style portlets. Well, let's discuss the relationship between portlets and Java EE. The portlet spec builds upon technologies found in Java EE, and I have them listed there on the right, a list of some of the Java EE technologies, and Portlet 3 is going to be standardizing on top of Java EE 7. So even though it relies on a lot of these technologies, whether under the hood, it does not fall under the umbrella of Java EE. But even still, Liferay Portal is relying on things like the Servlet API and so on under the hood, and developers like yourselves are typically relying on one or more of these technologies. Now, since a portlet's typically packaged in a WAR, you can do servlet-type things, and you can have a servlet container initializer or a servlet context listener and listen to when the context is initialized or destroyed. You can do things like, if you're using JSF or Vaadin for the UI, then you're going to be using other parts of Java EE. If you're using JSF, you're going to be using the expression language, perhaps bean validation. If you're going to do dependency injection, then maybe you're going to rely on CDI or perhaps Spring to do the dependency injection, perhaps scoping your beans and so on. So there is this relationship between these technologies that we just need to realize. And I want to take a minute to talk about CDI. Can I get a show of hands who's using CDI in their portlets? Oh, that's quite a few. Quite a few. Okay, more than I expected. Well, this is, for Java EE developers, this is a very familiar programming model. And I say familiar because CDI has been around for quite some time now, and sometimes we have portlet developers that come from the web app world, and now they're going to be developing portlets, and they want to take those skills and use them in a portlet environment. You'll be using annotations like @named in order to introduce your bean into the EL resolver chain. You'll be using annotations like @request_scope to take your bean and put it in a particular scope. You'll be using @inject in order to inject different dependencies and so on. And I have a demo of this. The Liferay Faces project has lots of different demos, and many of them kind of look the same. We have this standard applicant portlet. This is our reference portlet that we go to. And we have this thing implemented in plain JSF. We have it with CDI, we have it with Spring, we have it with Prime Faces, Rich Faces, Ice Faces, Liferay Faces, Alloy. And we basically exercise the typical use cases of inputting a form, doing some AJAX, uploading some files, and things like that in all these different types of technologies. And what I'm showing you here is the CDI version of it. And as you can see from the technologies listed below, we're using Mohara 2.2, we're using the bridge, and we're using the weld servlet jar. We'll talk more about that. And so there's a model managed bean for this. There's a backing bean and so on. So if I populate the model bean with some data, maybe I'll fill out this entire form here. I'm Neil Griffin, and I'll put in a phony email address, and I'll submit the form, and so on. Let's take a look at the code real quick for that. This is the backing bean right here. And you can see it has an @named annotation on it, and it's in request scope. So when I hit the submit button, it's the role of CDI to create an instance of this, and it lives as long as the request, and then when the request is complete, then it becomes available for garbage collection. If the @named annotation is on there, then I'll be able to identify this in some XHTML. So we'll just take a look at that. Under views, you can see in applicant.xhtml, we're referencing the model bean in EL. And when we submit the form, then it will be the backing bean. Bear with me. There we are. Okay, so there's the postal code listener for when we enter in a zip code or a postal code and then hit tab. So anyway, that's basically what CDI is responsible for in the background. And it's a nice, familiar programming model that you can use with Liferay today. The way you can do that is by adding this dependency, the weld servlet dependency, into your project. But for today, it has to be scope compile. And what that means is it's going to be embedded in the webinflib directory of your WAR. And that's fine, but it's not optimal. In the future, you can see here on the right, what our goal is to move from weld servlet embedded in your WAR to using weld OSGi bundle or a variant of it, and having that deployed as an OSGi module. So that way we'll be able to reduce the memory footprint. Anyone here ever used Glassfish before? Show of hands for Glassfish. I'm a big fan of Glassfish. Glassfish is built with OSGi, and there are some similarities between Glassfish and Liferay 7. Both rely on OSGi for the ability to deploy a WAR-based application. And the approach that Glassfish has taken is, in order to reduce the number of dependencies you have in your WAR and make it smaller, they're deployed as OSGi bundles. Now, there's a little bit of some engineering that needs to take place in order to make sure that something like weld OSGi bundle can be aware of servlet context initialization and things like that. So just putting it as an OSGi, deploying it as an OSGi module, it doesn't instantly work. So there's some things that need to be done that we're going to be doing for you, and I'll talk more about that. But this is the goal, to try and shrink the size of your WAR and to have as few dependencies in webinflib as possible. So today, maybe you have more than you'd want to, but in the future, that's the goal we're trying to pursue. Let's talk real quick about the Java EE module lifecycle. You saw a little animation there. You saw WAR fly across the screen there. Let me play that back again, if I can. There we go. And what it does is it deploys a context. So a WAR gets deployed to a servlet container like Tomcat, and ultimately becomes deployed as a context. The servlet spec requires that the classes for each one of these web apps is in its own class loader. And I've tried to illustrate the life cycle here. Of course, you're going to build your WAR, perhaps with Maven or Ant or Gradle. You'll deploy it, perhaps you'll copy it to Tomcat web apps. Then it undergoes context initialization. It either succeeds or it fails. Then when it's time for it to go out of service, or to be undeployed, you can just delete it from Tomcat Web Apps. It'll get a destroyed event, and then it goes into it's technically undeployed. Now, there are some familiarities here, but this is a dynamic module. Okay, this is something that we're familiar with. You can take a WAR, you deploy it to the server, it's in its own class loader, you can delete it, it's undeployed, and so on. But it doesn't have quite the robust lifecycle that OSGi bundles have. And if something fails in context initialization, anyone ever had something fail in context initialization before, right? What do you have to do? You got to redeploy the whole thing, right, in order to make it work. So there are some limitations to this model, and we're going to try and compare these later. And I think I have an animation on the next screen right here. That was done by my son, Paulie. Round of applause for Paulie, right? Nice to see Duke getting excited about OSGi, right? Let's play that again. I like watching it. Okay. Anyone have, Lego Star Wars or anything like that for their game console? And you see the guys building with bricks like that. That's what I said. Hey, can you put that together for me? So he did that with a tool called Blender. Well, Liferay 7, of course, is using OSGi to achieve modularity. And when you deploy a WAR to Liferay 7, it's no longer being deployed to the app server. The app server is not the one handling that. And there are many benefits in Liferay 7 to that. Instead, they're deployed as OSGi modules. So in Liferay 6.2, perhaps you would copy it to the Liferay deploy folder, and it would end up in Tomcat Web Apps. But in Liferay 7, if you deploy it to the deploy folder, it's going to end up in the WAR folder. I'm not going to labor this slide right here. This is just here for your reference to describe what an OSGi bundle actually is. It's a simple jar, except the manifest has some additional OSGi metadata in it. And we have to remember when we're doing OSGi, we want to have the mindset of avoiding scanning the class path and avoiding trying to do things like class.forename. These are things we're not supposed to be doing in an OSGi environment, if at all possible. And that's important because we need to consider that when we talk about the life cycle of a WAR. Well, here's the OSGi life cycle. And the build process is actually very significant here because let's say we're going to use something like the B&D Maven plugin, and we're going to be using Declarative Services and things like that. The build process is actually what's scanning for annotation, so to speak, okay, and discovering all that annotated information at build time. Then we'll copy the file over to Liferay or to Equinox or whatever container we're using. It goes into the installed state. Then the resolver does its magic to try and discover all the service dependencies that are there and tries to inject them into the bundle that's running. Then it will go into the resolve state, then the starting state, the active state, and it remains in the active state until perhaps you fire up the go-go shell and you stop it, or perhaps one of its dependent services goes away. And if that happens, then it will stop and go back into the installed state. Okay? And once the service becomes available again, then it will resolve and it will start up, and so it has a much more robust life cycle. So let's talk about a WAB. That's in the title of this talk. WABs are true OSGi bundles. And they have a Java EE web app archive layout, so it's a very familiar layout if we're a Java EE developer. And optionally, they have some embedded dependencies. So a WAR is just a jar, really, only a little more so. And it has a specific layout. It'll have a webint folder with a web.xml descriptor. Nowadays, that's optional. The compiled classes will be under webint classes, and then maybe we'll have some dependencies, some embedded dependencies under webinflib. So we're all familiar with this type of project. Well, when you take your WAR that you've just developed in your normal development environment, when you take this WAR, if you don't build it with anything special like the B&D Maven plugin or anything like that, you're just building it with a Maven WAR plugin. When you deploy it to Liferay 7, what it's going to do is it's going to look inside the manifest that's there. And if it finds a bundle symbolic name, it's going to say, this developer knows what they're doing, and they have pre-calculated all their OSGi metadata, they've got it right, it's already a WAB. Now, we don't support that in Liferay EE because it can be difficult in order to achieve perfection at that stage. And so what we've done is if you don't have a bundle symbolic name right there and you copy your WAR over to the Liferay deploy folder, then it says, oh, this is not an OSGi bundle yet, it's not a WAB. And it will transform it. And it will do all the necessary calculations to figure out what metadata needs to go into the manifest and put it in there for you and then start it up as an OSGi bundle. So a WAB is an OSGi bundle, and we've gone to great lengths to try and make sure that the WAB generator is doing its job. And if you'd like to look at the source for the WAB generator, you can take a look at that link at the bottom of the page. So let's compare this to CDI in Spring, the way it works. Well, let's say I'm using BND or the BND Maven plugin. When I use that tool, what's happening is services and injectable dependencies are discovered by the build time system. I mentioned this before, and they're satisfied at deploy time by the resolver. This is very different because what Spring and CDI do is during the context initialization event, they scan the class path, and that can be expensive. Okay, that can be expensive. It might, if you have megabytes of stuff there in your WAR, maybe there's a delay. Maybe there's a delay. So there are many benefits to actually doing this at build time rather than at deploy time. So that's the fundamental difference there, as I see it. So again, with service discovery, Java EE, in order to find all the beans and so on that are in my project, it's going to scan the class path. And that's something we want to try and avoid with OSGi. If discovery fails, or if a service dependencies cannot be satisfied, then the module is left in this error state, right? You try and visit your project, and you just get error messages. And you'll have to redeploy, as we discussed earlier, in order to fix it. So when we're using OSGi, hopefully these things are discovered at build time, and then the resolver will just bring our application online when all of its service dependencies are satisfied. Here's a comparison of the two life cycles. Same pictures we saw before, except here I have these blue word bubbles here trying to just to annotate what I described to you verbally before, that with OSGi, particularly with BND, the annotation discovery happens at build time, whereas on the top there you can see service discovery is done by scanning the class path. And then it instantiates everything with class.forename. So these are really two very different approaches to services and dependency injection and so on. So declarative services. One question that I've seen in the forums is, can I use OSGi declarative services with a Java EE type of portlet? The answer is yes, you can. You can inject services into it and so on. And I was at a talk earlier that I think it was called Don't Bet on the Wrong Horse, and it discussed all these different frameworks. It was comparing JSF and Vaadin and Angular and Liferay MVC and so on. And it was an excellent presentation. One clarification I'd like to bring is that for Java EE style portlets in general, it is totally possible to do this. And I'll show you an example. Okay. This here is the same portlet, except it's done with declarative services. So I just reloaded the page. It has the exact same functionality. Okay, I can fill out the form and so on. Well, let's take a look at the code for that. What I've done is this is a JSF portlet. Again, a Java EE style portlet does not automatically imply JSF. But here I've extended generic faces portlet, and I've put an @component annotation on it. I don't have a portlet.xml or a Liferay portlet.xml. And I'm using @reference right here to inject the Liferay user service. Okay? So this works. This works. There is one workaround we have to do for right now, and you can track this issue. It's LPS 66225. For now, you do have to have this special reference in there in order to make it work, because there's a thread timing issue that we're working through. But this will totally work. Now, in my activate method, I guess the drawback to this approach is, in order for my managed bean to know about these things that have been injected into my component, I need to save it off. And so one approach, not the only approach, one approach would be to save it in the servlet context as an attribute. So you can see here in the activate method, I just get the servlet context, I set the user service as an attribute, and then in the deactivate, when this portlet is going out of service, I can just remove the attribute to clean up. So it's just, for every new service I need to inject, it's another couple of lines of code. It's not a big deal, but it is one small drawback to this. And I'll just show how that works right there. I think if I punch in a postal code, that will invoke my, it will invoke my backing bean. So you can see right here in my DS applicant portlet down here in the applicant backing bean, I have a post construct in there. So when I entered the zip code, it went to the backing bean to try and look up what the zip code is. And in the post construct, I just consult the user service, I get the current user, and I did system error print line in order to make it red so that we can see it easily down below. So it works. It works. Service trackers. Another approach you could use, if you don't want to do it that way, is you could use a service tracker. And I have an example of it right here. The way you would do this is in your post construct, you would create a service tracker and then open it. And then in your pre-destroy, you would take the service tracker and close it. Now, you need to consult the service tracker. Here you can see the second bullet on the left. It says you need to call service tracker.isEmpty. If that returns true, that means the service is not available. It went away. So in this case, you're programming for failure. And we have an example of that. That's what we call the Prime Faces users portlet right here. You can download this from Maven Central and just drop it into Liferay, and then it will appear there in your control panel. Right? And let me just show you the code for how we got the data. It's consulting the user service. Okay, so it's in the model bean. And here we have a post construct. And I create an instance of what I call user local service tracker, and that's just a very small class right here. And I open it in the post construct, and then I close it in the pre-destroy, and then let me search for is empty. Okay, and if it's not empty, then I know that the service is there. I can consult it, and I can get all the users, and I'm good to go. If it is empty, then I have to create an error message right here. You can see add global error message and alert the user saying the service is temporarily unavailable. So if you're going to use service trackers, you're programming for failure. Well, what about the future? We know about what WABs are. We've seen how we can use OSGi in our Java EE style portlets. What about the future? Well, the future is Portlet 3, and to some extent, if you're a JSF developer, JSF 2.3, and the future is there on the license plate. It's RFC 0193, and that's this document right here. The OSGi Alliance is forming an RFC for this. This is a specification that lists the requirements for how do we have CDI, how can I inject something from the OSGi service registry into a CDI bean? Similarly, how can I take a CDI bean and publish it in the OSGi service registry? That's what this is all about. And I'm happy to report that Liferay has begun implementing this. Okay. And you can see here, there's a link to my GitHub account right here. And I can't get on, okay? Taking too long. I don't know what's wrong with the connection. Okay, we'll let that load. So we have begun to implement this, right? And it's important because we need this for Portlet 3. Okay? In order to support Portlet 3, we're going to need this technology because I won't labor this slide. It just lists all of the CDI type of features that are going to be present in Portlet 3. So adopting CDI might be a very attractive programming model for your Portlet environments. Well, this is something that we want to provide for you with Liferay 7. It's not, that you're going to have to wait for this until the next version of Liferay that supports Portlet 3. It's just we don't have a date on when this is going to be done. So what are you going to do for today? That's the question. What do I do? If you want to adopt the CDI programming model now, then you want to simulate to some degree what RFC 193 is doing. And you can do that by doing a CDI producer and disposer, and I'm going to show you that in a minute. The producer is going to create an instance proxy of whatever your service is. Whenever you call any method on there, it's going to check a service tracker to see whether or not the service is really there. If it's there, then it will proceed and call the method. Otherwise, it will throw an exception. Now, that would mean you'd have to have a try-catch block around your calls. And if you don't want to do that, perhaps if you're using JSF, maybe you'll create an exception handler so you can move all that logic up into an exception handler, something like that. And I have a link here to the code that I'm going to show you right here. It's just a few classes that you can take a look at your leisure. But it's found right here in the CDI portlet. So here's my producer. Okay, let me just zoom in right here. So in my CDI producer, this is something that's going to produce a user service. Okay, it's a form. It's what a producer is, a factory. It's just the CDI terminology for a factory. And so when CDI sees an @inject for a user service, it will say, oh, I have a producer for that. And what we do is we create a service tracker, and we open it. We create a new proxy, and in the proxy right here, we pass the service tracker. So let's take a look at that right here. This is a generic type right here. And so we just pass the service tracker in. And whenever someone calls any method on that service, we check the service tracker to make sure it's not empty. If it's not empty, then we call it. If it is empty, we throw a service not available exception. And this, in this definition, is a runtime exception. And so we can put a try-catch block around it if we want, or we can move that logic up into a JSF exception handler. And that's actually what we're doing here in the CDI applicant portlet right here. I have that same post construct in there. Here you can see an @inject. We're doing an @inject for the user service. And if I look for a post construct, you can see we're doing the same thing, except I have a try-catch block around it. So the way CDI is able to inject the user service is because the producer is producing something that looks like a user service, smells like a user service. It's just a proxy around it. And we have a try-catch. We're programming for failure. So that's a way to get very close to at least one part of the benefit of RFC 193. I've got about a minute left. Okay, so here's a summary for what we learned today. You have a choice. You can develop your Java EE-style portlets using declarative services. Right? The benefit is that you get the full life cycle. So if your portlet will go out of service when any of its dependent services are unavailable. And you can do configuration by annotation. You don't have to have a portlet.xml. It's very nice. It is a vendor-specific solution, but it's very nice. One drawback would be you have to, for everything that you inject with an @reference, you may have to store it in a servlet context attribute so that your beans will be able to discover it later, then you'll have to clean up. And unless Liferay decides to fortify B&D with some build time scannings, we're not going to be able to instantiate these. CDI is not going to be able to instantiate that. That's some internal discussions we have to have about the design. Or you can develop your portlets today by extending generic portlet or generic faces portlet, and you'll have the ability to do the CDI programming style, looking forward to Portlet 3 or perhaps JSF 2.3. But in the short term, you're going to need to embed weld servlet within your WAR, and you'll need to have a portlet.xml descriptor. So there's trade-offs. Okay? And I used up all the time. I am available for questions afterward if you have any. Are we able to take any questions, or do we need to?
Maybe one.
Okay.
Anyone have a question?
Are there any questions?
a really important one?
Okay.
No. Okay. Well, thank you, Neil.
Okay, great. Thank you for coming.